everyone, I am Ms.SOWMIYA from SA Engineering College in the Department of CSE AAML. Now I am going to take about a topic merge sort. So before that, we want to know what is meant by sorting. So sorting is nothing but arranging the elements either in an ascending order or by descending order. So by default we can go with an ascending order. So by using this merge sort we can also sort the elements. So here this merge sort follows divide and conquer technique. So divide and conquer technique is nothing but consider there is a large problem. So consider there is a large problem and this problem is divided into so many subproblems. So this problem is divided into so many subproblems. After that, we want to find the solution for each subproblems. So we want to find the solution for this subproblems. After that, we want to find the solution for this subproblems. And finally, we want to combine all the solutions into original solutions. So this is known as divide and conquer technique. So here the merge sort repeatedly divides unsorted elements into two parts. Sort them separately and merge them correctly. So here is our example. So this is our unsorted elements, which is nothing but 50, 60, 10, 70, 30 and then 40. After that, we want to write the index value for each element. So our index value will start with 0. For the element, here the index value is 0 and for 60 the index value is 1 and then 10 the index value is 2, 3, 4 up to 5. Then I have represented the lower bound and higher bound. For the index value 0, I am representing as the lower bound, and for the index value 5, I am representing as the higher bound. After that, we want to divide the elements into two parts based upon the mid value. So for that purpose, we want to calculate the mid value. So we want to calculate the mid value. So here is the formula. Mid is equal to low plus high divided by 2. Here the lower index value is 0. So mid is equal to 0 plus higher index value is nothing but 5. So 0 plus 5 divided by 2, which is nothing but it gives us 2. So now our mid value is 2. Now the mid representing the index value 2. Now the mid representing the index value 2. So based on this, we want to divide the elements into two parts, which is nothing but from low to mid and from mid plus 1 to high. Here the low to mid is nothing but, here the lowest index value is 0 from mid 2. So 0 to 2 and then mid plus 1 to high. So which is nothing but 3 to 5. So here is we want to divide these elements into two subparts. So one is from low to mid and another one is from mid to high. And then again we want to divide the unsorted elements into two parts, which is nothing but 50, 60 and 10 and then 70, 30 and then 40. Again we want to continue the same process. For each subparts we want to calculate the mid value. So here the mid is equal to low plus high divided by 2, which is nothing but the low index value is 0 and then the high index value is 2. So 0 plus 2 divided by 2, which gives us 1. Now the mid value is 1. So here also we want to do the same process. So here is the element 70, 30 and 40. The index value is 0, 1 and then 2. Here also we want to calculate the mid value. Mid is equal to low plus high. So the lower index value is 0 and then the higher index value is 2. So 0 plus 2 divided by 2, which gives us 1. Now the mid value is 1. So here the mid representing the index value 1, here also the mid representing the index value 1. So based on this we want to divide the elements into two parts as usual, from low to mid and from mid plus 1 to high. So again we want to divide this subparts into another subparts. Here also we want to calculate the mid value. Here mid is equal to low plus high divided by 2, 0 plus 1 divided by 2, which is nothing but mid is equal to 0. Here also the same process will continue. So we want to divide the elements recursively until it contains a single element such as 50, 60, 10, 70 and 30 and 40. So after that we want to compare each and every element and then sorted them in an order. So we need to compare the elements 50 and 60. Before that we want to consider this as I and this element as J. So here we want to compare the element 50 and 60. So it is already in an arranged order. So just I have already written as 50 and 60 and then 10. After that we want to compare 70 and 30. So 30 is less than 70. So we want to write 30 here and then 70 and then 40. Then we want to compare I and J. So consider this is I and this is J. So we want to compare 50 and 10. So 10 is less than 50. So here the 10 will be placed into new array. After that the J value will be incremented to the next position. So incremented to the next position, there is no element in this place. So the remaining element will be automatically stored in the new array. After that we want to compare 30 and 40. Sorry. After that we want to compare 30 and 40. So here 30 is less than 40. We want to store the element 30 in the new array. Then I value will be incremented to the next position. So I value will be incremented to the next position. After that we want to compare 70 and then 40. So here 40 is less than 70. So we want to add this element into the new array. 40. So again this J value will be incremented to the next position. So here there is no element. So automatically it stored the 70 in the new array. So for every step we are getting the elements into unsorted order. So here there are two subparts. One is 10, 50 and then 60 and another one is 30, 40 and then 70. So consider this position as I. So here the index position is 0, 1, 2. Here also the index position is 0, 1 and then 2. So I is in the position 0 and here J is also in the position 0. So we want to compare 10 and 30. So 10 is less than 30. So 10 will be stored in the new array. After that the I value will be incremented to the next position. Here the I value will be incremented to the next position. Now we want to check 50 and 30. Here 30 is less than 50. So 30 will be placed in the new array. Then J value will be incremented to the next position. Now we want to check 50 and 40. We want to compare 50 and 40. So here 40 is less than 50. So 40 will be placed in this new array. Again the J value will be incremented to the next position. After that we want to compare 50 and 70. So 50 is less than 70. We need to place the 50 in the new array. Again the I value will be incremented to the next position. Now we want to compare 60 and 70. So here 60 is less than 70. So we want to place the 60 in the new array. After that, again the I value will be incremented to the next position. So here there is no element in this place. At that time it will take the remaining element into the new array. So this is the process of merge sort. So now the elements are in the sorted order as 10, 30, 40, 50, 60 and then 70. So this is our whole process of merge sort which I explained before. Next we can move time complexity of merge sort. So time complexity of merge sort is considered T of 1 is equal to 1. So T of 1 is equal to 1. So here T of 1 is nothing but time complexity of 1. If it is one element, then it will be 1. And the next one is T of n is equal to T of n by 2 plus T of n by 2. Here T of n is nothing but here the problem is divided into two subparts, which is nothing but T of n by 2 plus T of n by 2 and then plus n. So plus n is nothing but n comparison. We want to compare each and every elements. So here T of n is equal to T of n by 2 plus T of n by 2 plus n. So here 2 T of n by 2 plus n. So this is the equation number 1. Here we want to substitute this n by 2 in place of n in equation 1. So we know that the equation 1 is T of n is equal to 2t n by 2 plus n. We want to substitute n by 2 in place of n. So T of n is equal to 2t of n by 2 plus n. So now we want to place n by 2 in the place of n. So T of, here is the n, we want to place n by 2. N by 2 is equal to 2t n by 2 by 2, which is nothing but n by 4 plus n by 2. So 2t n by 2 by 2 is nothing but n by 4 plus n by 2. This is equation number 2. So we want to again substitute this equation 2 in equation 1. So this is our equation 1. We want to substitute this equation 2 in equation 1. So finally we get the equations of T of n is equal to 2 square T of n by 4 plus 2n. We want to just substitute T of n by 2 equation in equation 1. We can see T of n is equal to 2t of n by 2 plus n. So T of n is equal to 2. T of n by 2 is nothing but this equation 2t n by 4 plus n by 2. So we want to apply here. So 2t of n by 4 plus n by 2 and this n. So it gives us 4t n by 4 plus 2 into n by 2 plus n. This 2 and this 2 will be cancelled. So finally we get 4t n by 4 plus n plus n. So it gives 4t of n by 4 plus 2n. So this 4 can be written as 2 power 2 t of n by 4 plus 2n. So again we want to substitute this n by 4 in place of n in equation 1. So if we place in equation 1, we will get the result as 2t of n by 8 plus n by 4. After that, we want to substitute the equation 4 in equation 3. So equation 3 is nothing but t of n is equal to 2 square t of n by 4 plus 2n. So we want to substitute the equation 4 in equation 1. So here we will get the final answer as 2 power 3 t of n by 2 cube plus 3n. So here 2 cube is nothing but here is our 8. So 8 will be written as 2 power 3. So this is our equation 5. So here this equation can be written as t of n is equal to 2 power, instead of 3 I am writing k here. So 2 power k t of n by 2 power k plus kn. So here is our stop condition. N by 2 power k is equal to 1. After that n is equal to 2 power k. Here k is equal to log n base 2. So we want to substitute here. So 2k is nothing but n. T of n by 2k is nothing but again n plus kn, which is nothing but log n base 2 into n. Again this n and this n will be cancelled. So here n into t of 1 plus n log n base 2. So we want to choose here highest degree. Here the highest degree is n log n base 2. So finally the time complexity of merge sort is nothing but big O of n log n base 2. So here is our gate question. Assume that a merge sort algorithm in the worst cases takes 30 seconds for an input of size 64. So here the n value is 64. It takes 30 seconds. Which of the following most closely approximates the maximum input size of a problem that can be solved in 6 minutes? So here is the solution. So here is the solution. So we know that the time complexity of merge sort is big O of n log n. So here the input is nothing but n is equal to 64 and it takes the worst case 30 seconds. So here is the formula, k into n log n is equal to 30. Here the n value is nothing but 64. So 64 log 64 is equal to 30. Here 2 power 6 is 64. So here k into 64 into 6 is equal to 30, which gives us k is equal to 5 divided by 64. So again, here is another step. Let n be the maximum input size of a problem that can be solved in 6 minutes. So here the minutes are given. We want to calculate the input size. So here also the same formula will be applied. K into n log n is equal to 360. This 360 is nothing but here 6 minutes is converted into the 60 seconds. So 6 into 60, which is nothing but 360 seconds. So we want to, now we know the value of k. 5 divided by 64 into n log n is equal to 360. So here n log n is equal to 360 divided by 64 by 5, which is nothing but 72 into 64. So this 72 can be written as 3 power 2 into 2 power 3. 64 can be written as 2 power 6. So 3 square is nothing but 9. 2 power 3 into 2 power 6 which is nothing but 2 power 3 plus 6, it will give 2 power 9. So this can be written as 2 power 9. So here the 2 power 9 is nothing but 512. Here the maximum input size is 512. So our answer is 512. So thank you. We will continue on next session.